Ever get that feeling, when you're facing a choice, and it's not just like, this is better or worse than that. It's like the options are from totally different universes.
Oh, yeah, absolutely. That's a great way to put it. We're wading into some deep philosophical waters today, exploring exactly that kind of dilemma. It gets at the heart of rational choice, a concept philosophers have been wrestling with for ages. Can we really define what it means to choose rationally, especially when the options aren't easily comparable?
It's like our gut feeling sometimes screams, pick this. But then there's this whole theory, expected utility theory, that tries to put a mathematical lens on it.
Exactly. Expected utility theory, or EU theory, is this dominant framework in decision theory. It basically says the rational choice is the one that maximizes your expected utility. It's seductive, right? Trying to quantify these incredibly complex choices we face.
Yeah. And on the surface, it makes sense. But I think we all know from experience that sometimes just crunching the numbers on what seems like the best outcome doesn't sit right.
That's the exciting part. That's where things get really interesting philosophically, because sometimes our intuition clashes with what EU theory might prescribe. And those are the situations we're diving into today.
It's like we're putting EU theory on trial, right? Not just taking it for granted. We're looking for those cracks, those cases where maximizing expected utility just doesn't capture the whole picture.
Exactly. And luckily, we have an incredible guide for this journey. We're drawing insights from the Stanford Encyclopedia of Philosophy, specifically their exploration of normative theories of rational choice, rivals to expected utility. It's a goldmine for anyone wanting to grapple with these fundamental questions about choice.
So let's ground ourselves in the basics before we jump into the deep end. What are the fundamental building blocks of this EU theory? What are we working with here?
Okay, great question. So there are three main components. The first one is this idea of a utility function.
Utility function. Sounds fancy.
Don't let the name intimidate you. It's basically a way to represent how much you value different outcomes. You assign numbers to different possible outcomes based on your own preferences. Higher numbers, more you want it.
So say I'm deciding between staying in and watching a movie or braving the cold for a walk. Maybe I'd give watching a movie a utility of, say, 7 and the walk of 5 because I'm feeling lazy today.
That's exactly it. You're capturing your personal preference in that moment. The second piece of the puzzle is the probability function. Here, we assign numbers between 0 and 1 to different events, representing how likely you think they are to happen.
So if I think there's let's say, a 70% chance of rain during my walk, I'd slap a probability of 0.7 on that event.
Perfect. You're already a pro. And the last piece of the EU puzzle is the aggregation norm. This is the rule that tells us how to combine those utilities and probabilities.
Okay, so we have our personal values, our beliefs about what might happen, and now we need a way to put it all together.
That's it. And the standard way to do this is by calculating the expected utility of an action. You basically take each possible outcome, multiply its utility by how likely you think it is to happen, and add it all up. EU theory says the rational choice is the one with the highest expected utility.
Got it. So far, so good. Now, the source also talks about gambles and differentiates between lotteries and acts. Why is that distinction important?
It all boils down to the type of probability involved. A lottery is like, think of a coin toss or rolling dice. The probabilities are objective, they're out there, everyone agrees on them. An act, on the other hand, well, that's more about your subjective beliefs about how the world works. It's like deciding whether to invest in a certain stock. You're making a judgment call about the likelihood of different economic scenarios.
So lottery equals objective probability, act equals subjective probability. Both are gambles, and we're still trying to maximize expected utility.
You got it. The formulas for calculating expected utility just tweak slightly to account for this difference, but the core principle is the same. Now, here's where things get philosophically interesting. Is it our beliefs and values, our utilities and probabilities that determine our preferences? Or do our preferences come first and we sort of derive our utilities and probabilities from those preferences?
That's a mind bender, right?
It
It's
is.
like the chicken or the egg question, but for decision theory.
Exactly. One perspective is that our values and beliefs are fundamental. We have them, and they lead us to prefer certain actions based on their expected utility. The other view is that our preferences are the bedrock. We observe our consistent choices, and then we can work backward using math to figure out the underlying utility and probability that would explain those choices if we were maximizing expected utility.
Okay, so that's like, is reality shaping our minds or are our minds shaping reality? Right. And applied to decisions.
Perfect analogy. And this is where representation theorems come in. They try to establish a formal link between how a rational person's preferences should logically behave and this mathematical framework of EU maximization.
Theorems. Okay, getting a bit heavy here. Can you unpack that a little?
Sure. Basically, they say if your preferences follow these logical rules, then we can represent your decision making as if you were maximizing expected utility. And a key part of this is the idea of axioms.
Ah, axioms. Those fundamental assumptions we're starting with.
Exactly. So for objective probabilities, we have axioms like completeness, meaning for any two options, you either prefer one, the other, or you're indifferent. Then there's transitivity. If you prefer A to B and B to C, you can't logically turn around and prefer C to A.
Okay, yeah, those sound like pretty basic rules for consistent preferences.
They are. Then there's continuity. Small changes in probabilities shouldn't drastically flip your preference. And lastly, independence. Your preference between two options shouldn't change just because we add a third option that's combined with both in the same way.
Got it. So these axioms are like the philosophical foundation for EU theory, especially when we're dealing with objective risks.
Absolutely. And for subjective probabilities, the axioms are a little different, but they still capture these ideas of completeness, transitivity, and the like. One important one for subjective probability is a type of separability axiom, often exemplified by Savage's sure thing principle.
Sure thing principle. What's the philosophical gist of that?
Basically, it says, if two actions lead to the same outcome in a specific situation, your preference shouldn't be swayed by that shared outcome. Your choice should depend on what happens in the situations where the actions differ.
That makes sense. So these representation theorems are basically saying that if our preferences play by these logical rules, then we can model our decision-making as maximizing expected utility. But, as our source points out, a lot of the challenges to EU theory question whether these axioms are always valid.
Exactly. And that's where the real philosophical fireworks begin. Now we can dig into these fascinating challenges that push the boundaries of EU theory. The first one we'll tackle is the mind-boggling concept of infinite and unbounded utility.
Infinite utility. Okay, that definitely sounds like we're entering the realm of philosophical paradoxes.
We are. The challenge here is what happens when we have outcomes that could be infinitely valuable. Think of Pascal's wager, that classic philosophical argument. It essentially says, believe in God, because even a tiny chance of infinite bliss in heaven outweighs any finite cost you might incur in this life. The problem is, if an outcome has infinite utility, it messes with axioms like continuity. No matter how small the chance of winning an infinite reward, it seems like it would always trump any finite risk.
So are we even equipped to wrap our minds around the concept of infinite value? That's a philosophical question in itself.
It is. But even if we stick to finite utilities, we run into problems with unbounded utility, especially when there are infinitely many possible states of the world. This leads us to the St. Petersburg paradox. Imagine a game where you keep flipping a coin until you get heads, and your winnings double with each flip. The expected monetary value of this game is actually infinite. But would you really pay an unlimited amount to play?
No way. So there's a disconnect between the math and our intuition about what's rational.
Exactly. The tiny probabilities of winning those astronomical amounts just don't feel like they justify an infinite valuation. One way to bridge this gap is the idea of diminishing marginal utility. The more money you have, the less each additional dollar matters to you.
Right. So even though the potential winnings keep increasing, their subjective value to you plateaus.
Precisely. But there's a catch. If the payoffs themselves are already in terms of utility, meaning we're talking about your happiness or satisfaction directly, then the paradox can rear its head again. If your capacity for happiness is unbounded, then the expected utility could still be infinite, even if the money involved doesn't feel infinitely valuable.
So even if we acknowledge diminishing marginal utility for money, the problem of infinite expected utility can stick around if we think about happiness or satisfaction in a way that doesn't have an upper limit.
That's the crux of it. And then we have even more mind-bending thought experiments like the Pasadena and Altadena games and the Petrograd game. These are all scenarios with unbounded utilities where the expected value either leads to nonsensical results or doesn't even exist. And they often involve cases where one option is clearly better than another in every possible situation. Intuitively, you'd always choose the dominant option, right? But EU theory can struggle to give us a clear answer in these cases.
So we're questioning whether a theory of rational choice should always align with this intuitive idea of choosing the option that's better in every single scenario, especially in these edge cases.
Exactly. Now, philosophers have come up with some creative ways to address these philosophical problems. Some explore different mathematical frameworks for representing utility, like hyperreal or surreal numbers, which can handle infinity in more nuanced ways. Others propose alternative ways of comparing options, like Artha's relative utility or Collivan's relative expected utility. And some even suggest truncating probabilities, essentially ignoring extremely unlikely events, no matter how large their potential impact.
Truncating probabilities, huh? That raises some interesting questions about how we deal with those black swan events, those things that are unlikely but could have huge consequences.
It does. Is it rational to just ignore those possibilities, even if they're extremely improbable? These are tough philosophical questions. So, the philosophical problem of infinite and unbounded utility forces us to grapple with how we assign value and reason about extreme possibilities. Now, ready for the next big philosophical challenge to EU theory?
Bring it on. Let's keep pushing the boundaries of rational choice.
Okay, this one delves into whether all values can be compared on a single scale. We're talking about the philosophical problem of incommensurability.
Incommensurability, meaning some things are just so different we can't really say one is better or worse than the other on any meaningful scale.
Exactly. Imagine trying to choose between two very different career paths. One might offer financial security and prestige, while the other might be more fulfilling but less lucrative. Or think about deciding between spending time with loved ones or pursuing a passion project. Are these really comparable in terms of more or less on a single scale?
No, not really. There are different kinds of good, different values. It's not like comparing apples and oranges. It's like comparing apples and the meaning of life.
I love that analogy, and this directly challenges the axiom of completeness. If two things are truly incommensurable, it's not necessarily true that you prefer one the other or are indifferent. They might just exist on different planes of value. And it can even mess with transitivity. If we try to force an indifference relationship onto incommensurable options, we can end up with weird preference cycles that violate the logic of transitivity.
So it's not just that we don't know which is better, it's that the very idea of comparing them on a single scale might be flawed.
Precisely. Now, philosophers have come up with different ways to understand this. Some say there is a fact to the matter about which is better. We just don't always know it. Others say it's a kind of vagueness in our values. And some argue that in these cases, the options simply can't be meaningfully compared.
So it's about recognizing different types of value and not trying to force them into a single hierarchy.
Exactly. Now, how do we actually make decisions when faced with this incommensurability? One approach is to represent preferences with not just one, but a set of utility functions, each capturing a different dimension of value. If one option is better according to all the functions, great. But if different functions point in different directions, well, that reflects the underlying incommensurability.
So it's like acknowledging that there are multiple valid ways to look at the situation.
Exactly. And then there are different rules we could use to make a choice when we have these sets of utility functions. Some say choose anything that's best according to at least one function. Others say pick anything that's not worse than something else according to all the functions. And there are other principles as well.
So it's about finding ways to navigate decisions when we're dealing with fundamentally different kinds of value.
You got it. Incommensurability forces us to think beyond simple comparisons and acknowledge the richness and complexity of our values. Now, are you ready for another philosophical challenge? This one deals with the fact that we rarely have perfect information about the future.
I'm sensing a theme here. It seems like EU theory loves its nice, neat probabilities. But real life is messy.
You're absolutely right, and that's where imprecise probabilities or ambiguity comes in. EU theory typically assumes we can assign a precise probability to each event. But in reality, we often don't know the exact odds, and sometimes we can't even pin down a precise range of possibilities.
Yeah, like I might have a vague sense that the stock market is likely to go up, but I couldn't tell you the exact probability of it rising by, say, 5% in the next month.
Perfect example. And this philosophical challenge of imprecise probabilities throws a wrench into the EU framework. It raises the question of what's rational when we lack precise knowledge about likelihoods.
It's like we need a theory of decision-making under uncertainty, not just risk.
Exactly. The source highlights several reasons why probabilities might be imprecise. One is that people tend to treat subjective or unknown probabilities differently from objective ones. Think about the Ellsberg paradox. People prefer to bet on a bag with a known ratio of red and black balls, even if another bag has the same possible range of ratios, but the exact mix is unknown. It's the lack of precise knowledge that makes them hesitate.
So even if the expected outcome is the same, the feeling of uncertainty can make a difference in our choices.
It can, and sometimes the evidence just doesn't support a single precise probability, or the evidence might be weak or unreliable. So we're dealing with a genuine lack of knowledge, not just a lack of confidence.
It's about acknowledging the limits of what we know and letting that inform our decisions.
Precisely. So if we accept that imprecise probabilities are a reality, how do we incorporate them into our decision making?
That's the million-dollar question, or maybe the infinitely valuable question, given our earlier discussions.
Ha ha, you got it. Well, one way is to represent those imprecise probabilities as intervals or sets of possible probability functions. Instead of saying the probability is zero point 0.6, we might say the probability is somewhere between 0.5 and 0.7.
So we're widening the net, acknowledging a range of possibilities.
Exactly. But then we need rules to tell us how to choose when we have these ranges or sets of probabilities. We have things like gamma maximin, a very cautious approach that focuses on the worst-case scenario. Gamma maximax is the opposite, focusing on the best-case scenario. And there are others, like the alpha maximin criterion or Choquet expected utility, which bring in other philosophical considerations about our aversion to uncertainty.
So lots of different ways to navigate the murky waters of imprecise probabilities.
There are, and they all reflect different philosophical attitudes towards the unknown. The challenge of imprecise probabilities really forces us to examine the nature of belief, the limits of knowledge, and how we should act when we're not sure what the future holds. But wait, we have one more challenge to EU theory to explore.
Hit me with it. What else have we got?
This one gets at something deeply human, our aversion to risk. It challenges the simple idea of maximizing expected value because it recognizes that we don't always treat potential gains and losses symmetrically.
Risk aversion. Yeah, I definitely feel that. A sure thing, even if it's a bit smaller, often feels more appealing than a risky gamble with a slightly higher expected payoff.
Exactly. And EU theory often explains this through diminishing marginal utility. The more you have of something, the less each additional unit matters to you. But some philosophers argue that this isn't the whole story.
So there's more to risk aversion than just how much we value each additional dollar.
That's the idea. Think about it. Two people could have very different attitudes toward money. One might be a cautious saver, the other a free spender. But both could still be risk-averse, meaning they both prefer a sure thing over a gamble with the same expected value. This suggests there's a more general aversion to uncertainty itself.
So it's not just about the money, it's about the discomfort with not knowing for sure what will happen.
Exactly. And there's a theorem, Radbin's calibration theorem, that shows how tricky it is for EU theory to explain observed levels of risk aversion. It basically says that even a small degree of risk aversion in small gambles would imply an extremely high aversion to risk in larger gambles if we were truly maximizing expected utility. And that just doesn't seem realistic.
So our actual behavior doesn't seem to match what the theory would predict.
Right. And then there's the Allais paradox. This is a classic example that shows how our preferences can be influenced by the presence or absence of certainty in a way that contradicts EU theory. People often choose a sure $1 million over a gamble with a slightly higher expected value, even though EU theory would say they should go for the gamble.
It's like certainty has a special value that goes beyond the pure numbers.
Exactly. So to address these challenges, philosophers have come up with alternative frameworks. Some try to incorporate psychological factors like regret or the feeling of certainty into EU theory. Others propose completely different decision-making principles, like incorporating measures of riskiness directly into the utility function.
So we're trying to capture those subjective feelings about risk in a more formal way.
Precisely. But even these alternative approaches have their own philosophical problems. There's a lot of debate about how to best account for risk aversion without sacrificing other important principles of rational decision-making.
It seems like there's always another layer of complexity to uncover.
That's the beauty of philosophy. There's always more to explore.
Well, we've covered a lot of ground today. We started with this idea of maximizing expected utility, and we ended up questioning the very foundations of rational choice. Infinite utility, incommensurability, imprecise probabilities, risk aversion. We've explored how all these philosophical challenges push the boundaries of EU theory.
We have. And it's not just abstract theory. These philosophical issues have real-world consequences for how we make decisions, both individually and as a society.
So for our listener, what's the main takeaway from all of this?
I think the biggest lesson is that while EU theory can be a useful tool, it's not a complete or universally applicable account of rational choice. There are cases where it breaks down or fails to capture the nuances of our decision making.
It's a reminder to be critical, right?
Yeah.
To not blindly accept a mathematical formula as the ultimate arbiter of what's rational.
Exactly. We need to be aware of the philosophical assumptions baked into these models. And we need to recognize that sometimes those assumptions don't hold up in the real world.
Sometimes the potential for extreme outcomes, like infinite utility, forces us to think beyond simple averages. Sometimes we're dealing with values that can't be neatly compared on a single scale. Sometimes our knowledge about probabilities is limited, and we have to make peace with uncertainty. And sometimes our feelings about risk, our aversion to the unknown, play a bigger role than just the numbers might suggest.
Couldn't have said it better myself. Recognizing these philosophical limitations can make us more thoughtful decision makers. It encourages us to consider the broader context, our values, our intuitions, and our relationship with uncertainty.
So, for our listener, the next time you're faced with a difficult choice, I encourage you to think beyond the simple calculation of expected utility. Ask yourself, are there any potentially extreme outcomes that might skew the results? Am I dealing with values that are fundamentally different and hard to compare? How confident am I in my knowledge about the probabilities? And how much does my aversion to risk play into my decision? Engaging with these philosophical questions can lead to more informed and authentic choices. And maybe, just maybe, it will spark a deeper appreciation for the complexity and wonder of human decision-making.